Okay, we have section 6.3, question E28. It's another binomial distribution question. How do I know it is? Because we're sampling 30 Americans. These are our 30 trials in the language of the text. And each P, so each probability that any given American will be below the poverty level is 0.132. So my P is 0.132, 30 trials, so my N is 30. First question, what's the probability that we'll have at least 2 people with incomes below? So this is one that we saw in video for P21 of section 6.3. And there we used an Excel spreadsheet with the binomial function. We could do that also. I'm going to show a different way. I can either calculate the probability of getting 2, probability of getting 3, 4, and so on, and then add those all up. That would be very time consuming. So instead, I'm going to suggest that we just look at probability of getting 0 and probability of getting 1. And then since we know that the total probability is 1, we can just subtract these two out and we'll have the probability of getting 2 or more with those lower incomes. So what's the probability that we will get none at this? Let's, instead of jumping straight to the binomial theorem, let's think about that. So the probability that a given person would not be below the poverty level is 100% minus this 13.2%, so 86.8%. So I'm going to put that here, 86.8%, 0.868. Now the chance of getting 2 of these people, if I just had a sample of 2, would be 0.868 squared. The chance of 3 would be 0.868 to the third. So the chance of the entire sample not having a person in poverty is 0.868 to the 30th power, which is very unlikely. Now the chance of 1 is a little bit different, and here it's probably, I'm going to try to still avoid using the formula directly. So here I would have 29 people this who are that above the poverty level times the chance of getting 1 that is below the poverty level. Okay. Now the thing is here, which one did I get that was the poverty? Was it the first one I chose, the second one I chose, the third one? And what we would really have to do is run through this same product for each of the 30 possibilities. Since we only have one of the 30 being poor, it could be the first, the second, the third, and so on up to the 30th. So since we would have 30 of these probabilities, we eventually just need to multiply that by 30. Now if you plugged it into the binomial theorem, this would be your n choose k. That would actually come first typically, and that would be 30 choose 1, because this is your k. 30 choose 1, this is your 1 minus p, and this is your p here. But I wanted to try to give a picture of where that formula is coming from. So if you calculate these two numbers and add them up, that will give you your 0.9204. Then we're looking at expected value and standard deviation. Well, expected value of any one person, so expected value of just a given person, let's say x, is 0.132. Since we can add these up, we can add expected values here. We have 30 of these, so the expected value for 30x is just 30 times the expected value of x, which equals 30 times 0.132. Okay. remember, standard deviation's a little trickier, but luckily we know what the standard deviation is of a normal distribution. So the standard deviation of a normal distribution is the square root of n p 1 minus p, sometimes this is written as q. So our n in this case is the number of trials, which would be 30. P, as we've said, is 0.132. Wow, I'm going to run out of room here. My apologies. And my 1 minus p then is 0.868. Okay, sorry about that crunch there. If I had wanted to use the formula for the mean of the binomial, the expected value of the binomial distribution is just n times p, which notice we had here's our n and here's our p. So we got that through a logic, but we could have also just used the formula directly. And this, if you work this out, take the square root, will give you this 1.85. Now this last question says we want to see if this national percentage is representative of our area. So we take a random sample of 30 people from our region, which would be incredibly hard to do realistically, but we did it, hooray. And how many of those people would have to live below the poverty before we started thinking that maybe we had a high poverty region? Well, 4 certainly wouldn't do it, because that would be exactly at the national average. It would be just a hair above, but certainly nothing to give us cause for concern. What about 5? Would that be enough above the national average that we think there's something going on here? Or 6 or 7? How can we tell? Well, there's no specific right or wrong answer here, but there are some kind of guidelines. So notice that if we go 1 standard deviation above this mean, there's not going to be, we're going to be quite a bit above the mean. In fact, there's only going to be about 15% of the samples would be 1 standard deviation above the mean by chance. So our standard deviation, or mine in this problem, is a little under 2. If I add that on top of my mean, I'm going to get 5.8 something. So if I had 6 people, I would be more than 1 standard deviation above the mean in terms of the number of poor people in my sample. So I would start to believe that maybe there's something here to investigate. Now when we go into traditional statistical tests, the cutoff tends to be a little stricter. We want to be a little more sure that we're not just getting a randomly high sample based on the people we chose. So we might use a cutoff of 2 standard deviations above this mean. But even 1 above might give you cause for starting to wonder if you were living in a high poverty region.